Now that you've tried out the WatchFace sample code, it's time to do a deep dive to better understand the different parts of making a watch face. If you look at the project in Android Studio, you'll see it shares a lot in common with a regular Android Wear app, in that it has a phone project application and a wearable project. So they're built into an APK in the same way as a wearable app. You can even bundle a watch face in with an existing app, or multiple watch faces into the same APK, like we're doing here. However, one key difference is that watch faces are actually a service. They're not activities. If we look at Digital WatchFace Service, you'll see that it extends Canvas WatchFace Service. You'll also see that we define an engine class which extends Canvas WatchFace Service.engine. These classes are both defined in the wearable support library that you've seen earlier. The first method of interest is onCreate, which is called to initialize your service. The first thing we do is call setWatchFaceStyle and provide a builder of the attributes that we want to set for our watch face. You can see that we've selected variable sized peak cards here. We also only want peak cards to show for interruptive notifications. And finally, we disable the system UI time since our watch face is drawing its own time representation for us. The next part of onCreate is initializing resources. It's very important that you do as much of your allocation and initialization here as possible. So setting paint styles and loading and resizing large bitmaps should be done here. You definitely don't want to be doing expensive operations in the main draw code for your watch face, nor allocating and freeing objects, since that'll cause the refresh performance to suffer. The next step is the onTimeTick method. This method is called in ambient mode once every minute. This is the only time that Android Wear will call your code to update your watch face. We'll talk more about faster updates later. When your onTimeTick is called, you need to invalidate the canvas. This tells the framework that your canvas needs to be redrawn, and this is done in the onDraw method, which will be called later. The onDraw method is where all the drawing happens for your watch face. You need to run this code very quickly since it'll be called a lot, so hopefully you did all your prep work earlier in onCreate. You can see that we start by setting our pre-created calendar object to the current system time. Then we start drawing things. We fill the background with a solid color and then use the bounds object to provide the dimensions. You should always use the bounds object to calculate the width, height, or center of the display, and it'll work properly even on devices with an inset chin at the bottom. This is important in the analog watch faces where the hands must come from the center of the display. The canvas object has many methods for drawing. DrawRect here draws rectangles. DrawText draws text view. You can control how this drawing is done with the paint object provided as the last argument. These were configured in onCreate. You'll notice this use of is in ambient mode. This is used to decide whether we'll render the seconds value or put AM or PM afterwards when in ambient mode. Here we have the onPropertiesChanged method. This method is called to provide to you information about various special display support that you might need to implement. You can see here property burn-in protection. We do not use bold font on displays that have burn-in issues because the thick text will be wider than the shifting pattern applied to move the watch face around. You can see here we call setTypeface to implement this. And here we have property low bit ambient. This tells us if the display can only render simple colors when in low power mode. So what else is happening for interactive versus ambient mode? The onAmbientModeChanged method is called whenever a switch is made between modes. In the code, you can see it's changing the paint styles so they have different colors depending on the mode we're in. We also detect if the watch supports low bit mode. If it does, we toggle the anti-aliasing flag since that is not allowed on these watches in ambient mode. And here we call invalidate to force a refresh after the change. Otherwise, we'll be stuck with the previous display and will not match the mode we just entered. Finally, you'll notice an update timer call. This is important because we need to refresh the watch quickly when in interactive mode, but once per minute in ambient mode. Let's go to the definition of mUpdateTimeHandler. You can see we defined a handler earlier. We call invalidate to force a refresh and then decide if we should schedule another update later on. If we do, we set an update to occur in a fixed number of milliseconds. If we follow the dependency, we can see it is normal update rate ms, and this is 0.5 seconds. So the CPU will sleep between updates. The code is written in onDraw to draw colons for the first half of each second, giving a blinking effect. If you look at other samples like the Sweet Watch face, it does not use a timer and just calls invalidate directly from onDraw. This uses a lot more CPU power, but gives smoothly moving watch hands. Some of the other interesting features are support for time zones. We register a broadcast receiver so that our service will be notified when we change time zones. This happens more often than you think, such as when a user arrives in a new city on an airplane. You can see the code changes the time zone of our calendar object. It then calls invalidate so that onDraw will refresh the clock immediately. Android Wear automatically propagates the time zone change that the phone discovered to the wearable, so all you need to do is register the broadcast receiver to find out when other changes have been made. The time zone is retrieved here with the getDefault method. One other thing to note is that you'll also need to deal with any localization issues, such as drawing the time and date appropriately for different languages, in the same way that you'd have to deal with this on Android phones and tablets. Let's now go to OnDataChanged. You'll notice that this service implements a listener for changes in data items, just like we talked about for wearable apps. This is designed to handle updates from the configuration activities and change the UI to reflect the desired colors.